Okay, so today we're going to talk a little bit about crop trends. And this isn't going to be trends for prices of corn or prices of daylilies or anything like that because those are basically futures and that's unpredictable. So this is going to hopefully take a little bit different direction. Our population is going up in general. And more people means more energy is being used. More people is more food being needed. And energy usage is expected to rise 2 times as fast as population is. That has to do with the fact that third world countries, large countries like India, are utilizing more and more energy as their population moves more from poverty type systems into more United States types middle class systems, and they are demanding and utilizing more food and more energy. So here we have some population prediction websites. So this is, I'm not going to go through all of this again, but if we take a look at just the first paragraph, hundreds of thousands of years for the world population to grow to 1 billion. Then in 200 years ago, it grew sevenfold. And in 2011, the global population reached 7 billion. Today, right now, we're looking at about 7.6 billion. And that means we need to feed these people, we need to house these people, and we need to clothe these people. And it's entirely possible that by the end of the century, we will be at 11 billion people. How do we feed? How do we find the energy for? How do we find the resources for 11 billion people? Will we have exceeded the carrying capacity for the planet at that point? If we all ate on nothing but plant based diets, no meat, fish, anything like that, you could feed an adult on zero point 0.2 hectares of land. Right now, so we could feed everybody easily at 8 billion people. But if we're going to continue to eat the way that we want to eat, we need to increase our fertilizer usage. We know we have to have fertilizer. We can't grow plants efficiently without it. Now, think of the other things that we're going to need. We need mechanization. We need tractors and combines and all of the things to harvest the food efficiently. If you look at the difference between the United States and developing nations, our energy consumption, agricultural energy consumption, is about 2% of the energy in terms of tractors and mechanical equipment. It's about 10% of the energy in developing nations. That's not sustainable if we continue along those lines. We know our labor force is declining in agriculture. We know our labor force age is increasing in agriculture. That's going to bring on additional challenges in the future. Let's look at two different countries. Now, this is not really taking into consideration what we think might happen with the trade wars. Obviously, the trade wars dramatically impacted 2019's supplies and exports in this country. But as a general rule, we use two times the amount of cropland that they use, but they have 30 times our population. We are very industrialized. They are rapidly becoming the world's most industrial country. They have been producers of products and buyers of ag products until very recently. We tend to be buyers of products and more producers of agriculture products. So there's a lot of differences between the two countries, even though we are converging on a lot of different areas. If we are going to achieve balance in all of this, and if we believe balance is achievable, we have to have everyone with equal access to food. And we know that's not the case. We have to assume that agricultural energy usage can be balanced, that we can have enough energy for other things and for agriculture, that we have enough population to harvest and plant and do all of those other things, and the food supply can be spread around the entire globe equally. Is that really the case? I'm not sure it is. Right now, we've seen a 58 increase in global energy usage. In fossil fuels, we've seen a 58% increase in about the last 10 to 15 years. BP, just one company, claimed, you can see that's about 7 years ago, that they had roughly 53 years of petroleum left. Now, that's just one company saying that. We've talked about this. We know that may or may not be the case because of changing technologies. So we have no way of knowing if that's true or not. That is just one scaremongering possibility. But there's lots and lots of places that are saying that this might be a possibility, that we may have very little oil left. The reality is, whether we have 50 years of oil left or 500 years of oil left, we know that oil is going to run out at some point. This is actually kind of a cool website that talks about different countries and different energy usage. So if we take a look, you'll see here that they have total energy, crude oil, oil products, natural gas, etc., etc. So there's lots of things. If you look across the top, you can click on different countries and see things. Obviously, the data, this is from 2018. The data from 2019 has not come in yet. But you can see, if we just look at this, China's energy growth rate right now in total energy usage grew 3.7% in 2018. Rise in crude oil production in the U.S., 16.5%. Now, obviously, this year is going to be wonky. We might see some really weird statistics coming out, but you can click through the website if you want to and see all kinds of different cool statistics when it comes to global energy usage. Most of our protein depends on fertilizer. Our protein is fed crops. To grow crops, we require fertilizer. To grow crops that are fed to humans, spinach is a very great source of protein, but to grow crops that are fed to humans, you still need fertilizer. And 90+% of the energy consumed by the fertilizer energy goes toward making ammonia, which is the nitrogen for fertilizers. Is that sustainable? These are all things I don't answer the questions. I don't know the answer to some of these questions, but these are all things I think we need to think about in food production as population goes up and up. Grain prices are variable. Who knows what in the world's going to happen this year? We know that we've been really, really good in the last 75 years of increasing our yields, but that's also meant that income per acre has tended to decrease because we're becoming more and more efficient with our production. Maybe we need price support for selected commodities. Maybe we need price support for all of those commodities. In some cases, it's up to half of farm income is dependent upon these price supports that are in place. The challenge that we have with some of these things, with some of these little tiny farms, is that only encourages consolidation. Because the larger your farm is, the more dollar value you get. Even if the percentage is the same, the higher that dollar value is. The more it costs to buy a tractor or a combine or any equipment, the more likely you are to consolidate with somebody so you have more money coming in. Water's a big one. Water usage, we know that's, again, like oil, it's a finite resource. As people move out of poverty and out of third world countries, and that country comes up into more of a middle income standard of living, they're going to use more water. If we grow more crops, we're going to need more water. We know ag's a large consumer of water. In some areas of the world, much more so than others. Take a look at the restrictions that happened in California several years ago when they were under an extreme drought. They had all kinds of restrictions. So there's still, our changing climate requires California to move beyond temporary emergency drought measures and adopt permanent changes. Farmers lost lots and lots of crops to that. It's not just one individual crop in one individual state. Yes, this was from a couple of years ago. But he was saying hundreds of thousands of acres of vines and trees were pulled up because they didn't have the water to support that type of farming. Is that type of thing going to increase? Probably. We know the number of farms has decreased and the size of those individual farms has increased. The number of farm workers has increased. The average farm right now is using the equivalent of 1.2 full-time workers per farm. That basically means each individual farmer is farming by his or herself. That's it. That's not a lot of people. That's very efficient, but it's not a lot of people. Many, many small farms are actually part-time farms. The same thing is happening in the greenhouse industry, by the way. So if you look at the greenhouse industry, 75 to 80% of greenhouses are owned by people who do this as a hobby. They make less than $25,000 a year total sales from their greenhouse. It is nothing more than a labor of love to them. We are trying to find ways to diversify our farms and to hopefully increase profitability. We're doing that same thing in the greenhouse industry. So farmers might be selling not just corn for crops, for animals, but also for ethanol usage. They might be selling soybeans for tofu or plastic. So they might have a greenhouse that also does hanging baskets and yard art and furniture, and maybe there's another division of the company that does outdoor kitchens, things of that nature. So that diversification helps hold you together in times of more in times of crisis. This is something that we've seen all the time. Rural areas are decreasing. More and more people are moving out of rural areas. Urban areas are increasing, meaning also more and more urban people are moving into more rural areas as those cities get bigger and bigger and bigger. How many times have you guys heard somebody moved in and then they start complaining about the smell? Because cattle poo, sheep poo, pigs poo. There's a smell that comes across with these things, and you get complaints when city folks who've never been near this stuff move out into country areas. Brain drain might be an actual thing. The definition of brain drain is when you get a small town and the supposedly smart people are all told that to make something of themselves, they have to leave the town. And whether you're smart or not, what's happening is people are leaving the town looking for education, looking for work, looking for more affordable areas, looking for an easier life, whatever that may be. And so what you have is these towns that are left with an older population because all of the young people get out. This is an actual phenomenon. What can we do about this? Is this something that we need to do anything about? Is a town, a small rural town in Ohio, worthy of saving? If the answer is yes, then we need to find ways to save those. We do know that if you're close to a large city, it helps. Because what happens then is the people who grew up in these small towns really love being in those small towns, but they're close enough to a city that they can get the jobs and the affordable properties or the affordable apartments and food and things like that while maintaining their standard of living in their smaller, more rural town. So being closer to a large city does help this. This is a phenomenon that sociologists have been talking about for a long time. What can we do to convince people to stay in their town or to move back to their town so we don't leave some of these towns essentially dying because there's nothing left for anybody to do. And the more people move out, the fewer jobs there are, causing more and more people to move out. So it's a self-perpetuating cycle. Those are some of the things that have been trending lately. You can go online and look up any kinds of trends in terms of crop pricing, in terms of crops that are growing, in terms of ornamentals. We've talked about some of them, grow native, go local, those sorts of things. All of these are different trends. But what I wanted to concentrate on today was changes in population and how we as a society are going to need to manage those changes as we move forward with agriculture and plant production. All right, once again, you got any questions? Hit me up.